Here we're going to look at how the quantum mechanical explains things. So we know that chemical properties of elements are periodic, but why? It's because the number of valence electrons is also periodic. Elements in the same column have the same properties. Elements in the same column have the same number of valence electrons. And we also see patterns that repeat if we look in a period. So the number of valence electrons and the types of orbitals they occupy are also periodic, and thus chemical properties are periodic. So let's look at some of those things. The noble gases, these are group 8A. All the noble gases except for the baby hydrogen have 8 valence electrons. They are very non-reactive. Helium and neon are practically inert, which means it's almost impossible to get them to react with anything, right? So it turns out that atoms with 8 valence electrons, or 2 for the little guys, are particularly stable because their quantum level is full. And when that quantum level is full, the overall energy of the electrons is lower. And so they are more stable. They don't need to react with another element to become stable. The alkali metals, other end of the periodic table, these guys are very reactive. And yet they have electron configurations that are close to the noble gases. Well, this doesn't look close, but if sodium loses 1 electron, it has the same number of electrons as a noble gas, which is very stable. So the reason that the alkali metals are so reactive is because it's very easy for them to become more stable, have the electron configuration of a noble gas. They just need to lose 1 electron, and so they do that very, very easily. The halogens are on the other side of the noble gases, so they are 1 electron short of being like a noble gas. So these are also quite reactive, and they tend to gain 1 electron to have the electron configuration of their neighbor. So here's another one of my analogies. Electrons are on the outside of the atom, right? And the nucleus is on the inside. So the nucleus is like your soul, your personality, who you are, right? And the electrons are like what you look like. And you can change what you look like. You can do stuff with your hair, you can dress differently, all kinds of stuff, right? So I think of these noble gases as being, this is what everybody wants to look like. So the analogy I fall back on is high school, right? There's that group of in kids, right? And everybody's trying to look like them because I don't know why, but they are, right? So the alkali metals, they've got like this extra electron, like their mom made them wear a sweater or something. If they just take the sweater off, they'll look like the other kids that have it all together, right? And then the halogens are like mom not letting you wear that hat to school, and as soon as you get to school, you put that hat on because everybody else is wearing hats, right? Except you can't anymore because of gangs, but we could wear hats when I was a kid. So they gain an electron, right? So they're changing their electron structure to be like a noble gas. That make sense? So that explains all kinds of stuff. There are many metals and nonmetals that only form 1 ion, and the charge of that ion is based on the position in the periodic table. And the reason they form these ions is to get the same number of electrons as the nearest noble gas. They'll have the same electron configuration. Do they become a noble gas? No. If you dress like a monkey, it doesn't mean you are a monkey, right? You're still you. You can't change that. They don't change their nucleus, but the electrons can change. These are the predictable charges ones. Even in the newer edition, they numbered these wrong. which is kind of understandable. You know, they left off the hydrogen thing up here, so they started with 1. So, you know, correct that in your book. And I don't know what happened to these numbers, but they're slightly off. Anyway, you know, these guys, the reason that trick of counting backwards tells us what the charge is because we count backwards. This guy needs to gain 1 electron to be like neon. This needs to gain 2 electrons to be like neon. This one needs to gain 3 electrons to be like neon. And over with the metals, they need to lose electrons. Sodium needs to lose 1. It gets +1 charge. Magnesium needs to lose 2. Aluminum needs to lose 3. Notice we don't see any ions in group 4A. Why? Well, I think those are the guys that realized changing how I look isn't going to make any difference. I'm just going to own who I am, right? It's too hard. You either have to gain 4 electrons or lose 4 electrons, and it's not worth it. Okay? So I guess that's the kind of kid I was in high school. So the anions form when we have nonmetal atoms gaining enough electrons to have 8 valence electrons, and when that happens, the s and p orbitals of the valence shell are full. So if we look at sulfur's electron configuration, it ends with 3p4. To be full, it needs 3p6, right? So gaining 2 electrons, we fill that up, and now same electron configuration as argon. Cations are losing electrons. Here we've got magnesium. There's its electron configuration. And it's got these 2 electrons in the 3rd level, right? If you get rid of those, this is the same electron configuration as neon. And that's why magnesium forms a 2+ ion. Because when it removes 2 electrons, it becomes more stable. Any questions?